Here we have a SAT math problem. Okay, let's go to the question. A regular hexagonal prism has a volume of 350 cubic inches and a height of 14 inches. What is the perimeter of each of the hexagonal bases in inches? Round your answer to the nearest tenth of an inch. Okay, first let me take a regular hexagonal prism. Here we have a regular hexagonal prism, and for this prism we have the height that is 14 inches. So the height is 14 inches, and also we have the volume for this prism that is 350 cubic inches. So volume equals to 350 cubic inches or inches cube. Okay, here for the prism we have the formula to get the volume, that is the base area has to be multiplied by the height of the prism. So instead of we can write the formula to get volume of the prism, that is base area times height. On the right side we can write this value 350 as it is. Okay, here we know the height of the prism, that is 14. We can plug in this 14 for height h over here. Then I'm getting b times 14 equals to 350. Okay, now let's solve for base area in this equation. For that we have to get this 14. Let me divide both sides of this equation by 14. 14 will cancel out. Then base area equals to, when I divide this 350 by 14, I am getting 25. That is 25 inches square. Okay, here I got the base area. Actually, the base is a regular hexagon. That is, I got the area of the regular hexagon over here. Now, let me draw the base separately. Here we have the base of the prism, that is a regular hexagon. Okay, always we can split up a regular hexagon into 6 congruent equilateral triangles. Okay, let me do it. That is, let me split up this regular hexagon into 6 congruent equilateral triangles. Okay, here I got 6 congruent equilateral triangles. Actually, our aim is to get the perimeter of this regular hexagon, which is the base of the given prism. Okay, now let me assume the length of one of the sides of this regular hexagon is A. Since it's a regular hexagon, all the sides will be equal in length. Then the length of this side is A, this side is A, this side is A, this side is A, this side is A. So once I get the value of A, that is the length of one of the sides, it can be multiplied by 6 to get the perimeter of the hexagonal base. Okay, here each triangle over here is an equilateral triangle, so all the 3 sides will be equal in length. Already we know that the length of one of the sides of the triangle A, then the length of this side is also A, this side is also A. Okay, now what we can do is we can consider the area of this equilateral triangle with the side length A. So when we have the side length of an equilateral triangle which is A, there is a formula to get area of the equilateral triangle, that is square root of 3 over 4 times A square. This is a formula to get area of an equilateral triangle. Here the A represents the length of one of the sides of the triangle. Okay, here this gives the area of just one triangle. Now to get the complete area of this regular hexagon, I have to multiply this area by 6 because there are 6 congruent equilateral triangles. When I multiply the area of one triangle by 6, that is equal to the area of the regular hexagon. Already we got the area of the base of the prism, that is 25. So the base of the prism is a regular hexagon. So it is equal to 25. Now we have to solve for A in this equation. Okay, here we can do some simplification on the left side. That is 2 goes into 4 2 times and 2 goes into 6 3 times. Then I'm getting, let me continue over here. 3 times square root of 3 over 2 times A square equals to 25. Okay, now to solve for A in this one, we have to get this fraction over here. For that, we have to multiply both sides of this equation by the reciprocal of this fraction. That is 2 divided by 3 times square root of 3. Let me do the same thing on the right side as well. That is 2 over 3 times square root of 3. Here 3 square root of 3, 3 square root of 3 will cancel and 2 will cancel out. I am getting A square equals to, and here 25 times 2 is 50. That is 50 divided by 3 times square root of 3. Okay, now what we can do is we can take square root on both sides of this equation to get the exponent 2 over here. Okay, now let me do it. Okay, so here I'm taking square root on both sides and the square root and square root cancel out. Usually when we take square root on both sides of an equation, one of the square roots will cancel out, like what happened on the left side over here. And for the square root on the right side over here, we consider positive or negative sign. But here on the left side we have A, which is the length of one of the sides of this regular hexagon. It cannot be negative, so the length can never be a negative. So we can consider only positive sign instead of positive or negative. So we get A equals to square root of 50 over 3 times square root of 3. Okay, as I said earlier, we have to multiply the value of A by 6 to get the perimeter of the hexagonal base, because A represents the length of one of the sides of the regular hexagon. Now to get the perimeter, we have to multiply it by 6. Okay, now let me multiply this one by 6. I multiply both sides of this equation by 6. 6 times A is 6, then we get 6 times square root of 50 divided by 3 times square root of 3. Okay, now let's evaluate the value of this one. Okay, let me write the 6 here on the left side as it is. So that is 6 times square root of Okay, so here square root of 3 is an irrational number. The approximate value of square root of 3 is 1.732, and this value of square root of 3, 1.732, has to be multiplied by 3. When I multiply it by 3, I am getting 5.196. So that is the value of this 3 times square root of 3 is 5.196. That is 50 divided by 5.196. Okay, now what we can do is we can divide 50 by 5.196. When I divide, I am getting 9.622, a long decimal value for this one, that is 9.6227, keeps going. Now for that value, I have to take square root. When I take square root, I am getting 3.1020, and again I am getting a long decimal. So it has to be multiplied by 6. When I do so, I am getting 18.61 something. So that is 6a equals to 18.61 it keeps going, but our aim is to round the answer to the nearest tenth of an inch. When I round this one to the nearest tenth, so its value is 18.6 inches. Okay, here I got the perimeter of the each regular hexagonal base. It is 18.6 inches.